Hello everyone and welcome. In this video we're going to be talking about Koenigsegg's free valve system, and these are actually two different companies. They're sister companies, Koenigsegg and Free Valve, but we're going to be talking about their camless cylinder head design here, which uses an actuator rather than camshafts to open up the intake valves as well as the exhaust valves. And so this is a simplified version. I have a separate video that goes into, how do actuators work. This is an electro-hydraulic pneumatic, so using all the energy out there in order to, have the perfect valve opening and closing system. The process here is, though, pretty accurate about what they do. So basically what happens, and again, oversimplified version, it's going to be more complex than this. I'm not sure exactly what they're doing, but this is a good representation of how the system works. The more exciting part is definitely the advantages of this system. So you have this actuator right here and then a valve. Those are really your two parts. So what happens is you have an electronic signal. That electronic signal tells air to come in. So you have a valve here which allows air pressure to come in and pushes this piston down here, which is forcing this valve down, opening it up, allowing for airflow. Then you're going to have this oil pressure, which is going to lock this piston in place. So how this mechanism works could be many different ways. This is just a very simple pin that stops it and prevents it from going further. So it chooses that lift height. You could have different ways of doing this so that you could set it at any lift height. But basically the oil is there to stabilize it, lock it in place, make sure that that valve isn't kind of bouncing around as a result of having a spring on both sides. Then you're going to, once you've opened it up, you've let your airflow happen, you're going to release the air and oil pressure, and then you either have an air spring here or a mechanical spring or a combination of both, and that spring forces that valve back up, closing it, and you've gone through your valve actuation. So instead of using a camshaft, you're using air pressure really to open and close it, oil to lock it, stabilize it in place. So what are the advantages? This is the exciting part of this kind of system. And basically the biggest advantage here is that you have independent control of lift, timing, and duration of all of your valves for all RPM. So any individual valve you can control however you want. So looking here at a traditional camshaft, if you had a single cam profile, it'll open up, it'll go to its peak lift, and then it'll close back down. Open up, peak lift, and then close back down. With a system like this, however, you can instantly just go open, all the way open, leave it there because you don't have that cam profile that you're, required to use, so you can only have one peak point, so you can leave it there and then close it completely. And so that gives you a lot better airflow. Now that's, let's say you want to do that for high RPM. Well, for low RPM, you might want faster speed so you get a better air-fuel mixture. So you can use a smaller lift profile for a shorter duration at low RPM. So you have all these different options which you can choose rather than just that single cam profile, which is the traditional method of opening and closing valves. So that's the biggest advantage. It gives you a ton of control over each individual valve. Now, packaging and weight is also a benefit. You don't have that big bulky cylinder head with dual overhead cams or whatever it may be. You don't have to have a timing belt, so you can shorten the length of the engine or a timing chain. You can easily run the Atkinson cycle, and I have videos linked in the video description for a lot of these things if you're not familiar with how they work. Cylinder deactivation is very easy using these. You can control the valves individually, shut off any 2, 4, 6 cylinders, however many cylinders you have. You can play around with it a lot more. It makes it a lot easier to do than with traditional mechanical methods. You can eliminate the throttle body. So this is what BMW does with their Valvetronic system. You can do that exact same method with these, and that makes it significantly more efficient. That's why BMW does it, about a 10% efficiency gain just from having the throttle body wide open and having that pressure right at the valves rather than a vacuum between the throttle body and your valves. And then fully optimized, Koenigsegg says that this will give you 30% less fuel consumption, 30% more torque, 30% more power, and 50% less emissions. So, combining all of these benefits, that's kind of what it's going to come down to. So a ton of benefits of this system. So why isn't it seen in every vehicle out there? Well, two main reasons. Probably cost, because it hasn't been mass manufactured, so the cost is going to be high for those initial early adopters, and they may have some testing that still needs to be done, some kinks that need to be worked out of the system. So I'm betting on cost being the big driver there of why this isn't widely implemented, but the company Koros, Chinese company, did unveil a concept at the Beijing Auto Show in 2016 using this free valve system. So hopefully, as a result of this concept, we may start to see this come into mass production. So thank you guys for watching, and if you have any questions or comments, feel free to leave those below. This is my cat Bucket. You got anything to say for yourself, Bucket? Just biting your tail.